Lesson 3. Welcome to the third class of the Small School of Programming on the Commodore 60 Store in BASIC. Today we will continue to get to know the possibilities and commands of the C60 Store computer. Of course, as usual, we will give some advice and examples for what we are learning. Let's start with small tips and explanations. Software reset, interrupting the program and returning to basic settings. While working with the computer, it may happen that we cannot stop the program with the run stop key, ESC, on the emulator. Also, we can disturb the graphics, colors, hear a constant sound, etc. Therefore, we need something stronger, and that is achieved by pressing simultaneously two keys, run stop, restore, on the emulator ESC page up. In that way, we return the C64 to working condition with basic colors and settings. This combination even has the ability to interrupt the execution of some machine programs if they have not affected the system operation too much. Inserting characters. If we need to insert some text into the existing one, we bring the cursor to the desired place and press Shift-Ins-Del on the emulator, Shift backspace as many times as we want to create empty spaces for the desired text we are adding. Colors and explanation of the memory map. The C64 has the ability to work with 16 colors. If you want to change the color of characters on the screen by using the keyboard, it is easy to do. We will use the Control key on the Commodore, tab on the emulator, and get the first 8 colors by pressing the keys from 1 to 8. For the other 8 colors, we will use the Commodore key, Control on the emulator, and again the keys from 1 to 8. We also mentioned that Control 9 turns on and Control 0 turns off the inverse display of characters. One of the ways to change character colors by programming is the command print. For example, to get the white color of characters, we write print Control+. By pressing this combination, an inverse letter E will appear in parentheses. As for setting the color of the border and the background, standard C64 BASIC does not have these commands. How then to change their color? It is important to keep in mind that all Commodore's possibilities exist in the computer's memory map. The memory of the computer can be imagined as a pile of electric boxes labeled with numbers from 0 to 65535. Each of them possesses 8 switches, bits, which are turned on and off, 0 and 1 state of bit, 0 off, 1 on, by the user's wish or the need of the computer. If we assign each switch bit the following weighted values 1, 2, 4, 8, 16, 32, 64, and 128, by their combination we get any number from 0 to 255, taking into account 256 total combinations. Because of this fact, the Commodore is classified as an 8-bit computer. Some memory locations serve for writing data, basic programs, variable states, assembler programs, etc., while some are responsible for displaying characters on the screen, colors, sound, system operation, and everything else. Some we can only read, in some we can only write, etc. There are also some memory overlaps, but for us the most important thing is to know that by manipulating the values of memory addresses, we can achieve everything we need on the C64 computer. Now, how that goes with colors. Memory locations 53280 border and 53281 background contain values which the computer constantly reads, and based on these values it displays the colors of the border and background. Today we will learn an important command which allows us to manipulate the state of memory locations, and we will see from an example how it works. Sound. As with colors, there are no direct commands in Standard Basic for sound. To make sound be heard, we need to manipulate memory locations responsible for the musical capabilities of the computer. The C64 has 3 sound channels, 8 octaves per each channel, and many musical possibilities. According to many experts, the SID chip, which is responsible for the sound on the C64, was at that time the most advanced computer synthesizer among 8-bit computers. The memory locations responsible for all 3 musical sound channels range from memory address 5D4272 to 5D4300, and each of these locations is responsible for something: tone strength, shape, noise, etc. Graphics. As with colors and sound, for working with graphics, there are no commands in standard C64 BASIC. So here too, we must manipulate directly the values of the memory map. There is the textual mode, the one in which we immediately find ourselves when we turn on the computer, and there are displayed 40 characters in 25 rows with 16 colors per character. The high resolution mode 320 by 200 in 2 colors. In this mode, there are displayed 320 points horizontally and 200 points vertically, and the points are colored in the size of a character 8 by 8 in 2 colors, background and face of the character, and the multicolor resolution of 160 by 200 in 4 colors per character. In this mode, there are displayed 160 points horizontally and 200 points vertically, and the points are colored in the size of a character 8 by 8 in 4 colors. That is the reason why the horizontal resolution is half of the high resolution, and there are the background color, character color, and 2 additional colors. There are also hardware sprites, high and multicolor resolution, small pictures that move on the screen and that are often used when making games, especially of arcade type. There are 8 in total and much more. Let us for now stay at this short explanation. Let's start with today's lesson. Functions, commands that are not independent. Today we will pay attention to commands, functions which are executed by giving the command print and the name of the function or assign their values to one of the given variables. They affect the way of displaying the output on the screen or perform various calculations. Those functions which are used for manipulating screen output are executed by giving the print command, and those used for various calculations can have their results displayed or written into desired variables for later processing. Tab, printing on the screen in the desired column. The form of the function is tab A, what we display. The argument A can have a value from 0 to 255. Printing of the text starts from the place distant for A characters from the beginning of the line. Example 10 for 1 to 20, 20 print, tab I, shifted, 30 next, I. Pay attention that between the function tab and the bracket there must not be a space. By executing this short program, we will get 20 printed lines, of which each is shifted 1 character to the right in relation to the previous line. It will print the column number and the text shifted. SPC, printing on the screen in the desired column. The form of the function is SPC A, what we display. The argument A can have a value from 0 to 254. This function also prints text on the screen in the desired column. What is the difference? Unlike the tab function, this one prints by entering as argument A that many blank spaces in relation to the last printing position. Example 10 print display 1 SPC 10, display 2 SPC 5, display 3. Pay attention that also here between the function SPC and the bracket there must not be a space. By executing, we will get at the beginning of the line the print display 1. The cursor will move 10 characters and print display 2, and then move 5 characters and print display 3. POSA, determining the column number where the last character was printed. This function gives us the possibility to determine the number of the column in which a character was last printed. The form is POSA. The argument A can be any number. It is necessary to write it. Why? Only the computer constructors know that. Here's a small example of this function. 10 for I equals 1 to 10, step 2, 20, print tab I, P, POSA 1, 30, 30, next I. With this program, there will be displayed prints shifted 2 characters to the right in relation to the previous line, and at the end of each line, the letter P and its column position will be printed. INTs, rounding decimal numbers to whole values. The form of the function is INTA. Unlike previous functions related to the print command, the value of this one can be assigned to a numeric variable at our will. Keep in mind that this function will always round down the value to the lower whole number. For argument A, we can write any integer or decimal number or put any numeric variable. Decimals on the C64 are separated by a decimal point. Example, 10i equals 11.4, 20 print 10i, 30t, 5.7, 40, x equals 10, 12.8, 50, print x. When the program is executed, we will get the results 11, 5, and 12. As you can see, all numbers are rounded to the lower whole value. RND, generating random numbers. This function is often used in various programs and games. It generates random decimal numbers between 0 and 1. As with the previous one, this function's value can be assigned to a numeric variable. The form of the function is RNDA, where the argument A can have the value 1, 0, 9 is 1. When we put 1 as the argument, we let the computer know to generate numbers that are not completely random. These numbers that the computer shows are formed at the moment of turning on the computer, and there are 65535 of them, after which they repeat. With argument 0, we get numbers from the computer's built-in clock, and they are true random numbers. When the argument is -1, we also get a random number, which first sets a random starting value, and based on it generates the other random decimal numbers. Examples, 10 for I equals 1 to 10, print RND0, 30 next I. There will be displayed 10 randomly generated decimal numbers between 0 and 1. 10 for I equals 1 to 10, 20, x equals int RND of 0 tart after 50 plus 1, print x 30. Next I. Program lines 10 and 30 are familiar. In line 20, we gave the computer to round a random decimal value from to 1 multiplied by 50 and increased by 1. Thus, we got a random whole number between 1 and 50. Then we assigned it to the numeric variable x and displayed it with the print command. So what happens here? There will be displayed 10 whole numbers from 1 to 50, and some of them may repeat. We will continue with more functions in the next lesson, and for today we will still learn a very important command for manipulating memory locations and a function for reading their values. Poke, writing a value into a memory location. The format of the command is poke_mb, where the argument m is the memory location, 0x65535, and the argument b is the 8-bit value, 0x255. With this command, we can enter into any memory location in which writing is allowed any 8-bit value. When we talked about colors, sound, graphics, etc., we said that standard C64 BASIC does not have commands for working with them. This lack is compensated by using the poke command, which writes into corresponding memory addresses that are responsible for these operations the desired values that will give the requested result. If we enter for the memory location a number greater than 65535, or for the value a number greater than 255, we will get the error message, illegal quantity error. The following short example will demonstrate this command. 10 for I equals 1 to 17, 20 poke 53280, RN0 16, 30 poke 533281, 1640. For S equals 1 to 1000, next S50, next I. In line 10, we give a program loop with 17 cycles. In line 20, we enter into memory location 53280. This memory location is responsible for the border color, a random decimal number from 0 to 1 multiplied by 16. Keep in mind that the values for colors go from 0 to 15. Regardless, we multiply by 16 because the arguments in the poke command behave as in the int function, and only whole numbers are taken. And if there are decimals, they are rounded down to the smaller integer. Even if the obtained value is 15.9999, it will take number 15. In line 30, the procedure is identical, only memory address 53281 is taken, which is responsible for the background color. In line 40, we have a loop that counts from 1 to 1000 and apparently does nothing. In fact, this loop slows down the execution of the computer program so that we can better see the color changes. In the last program line, the variable I is increased by 1 and it is checked whether it exceeded the value 17. If not, the program returns to line 20. And if yes, the main loop ends, and since there are no other commands, the program stops working. Peek function that displays the content of a memory location. The format of the function is peek m. This function reads the value of the given memory location from 0 to 65535 and displays it or stores it in a variable. Example, 10 print peek 53280, 20x equals peek 53281, print x. This small program will display the value of the border and background color. Do not be surprised when you get a large number. Namely, since these memory locations need 16 combinations for colors, they use the 4 lower bits for them, and the remaining higher 4 bits are set. Because of that, you should subtract 240 from the displayed number, and you will get the desired value. With this, we finish for today. The lessons we have covered so far are here to tickle your curiosity so that you yourself start exploring the interesting things and possibilities of retro computers. Enjoy them.